Hello students, myself Dr. Jyoti Shegokar. I welcome you all in my YouTube channel which is made for the study of engineering chemistry and its name is Dr. Jyoti Dhumale Shegokar. Now our today's topic of discussion is EDTA method for the hardness determination. Before these we have seen number of videos which are related to the water, that is determination of hardness, types of sources, types of different impurities present in water, and now that impurities creates hardness. Hardness is nothing but that property of water which consumes soap, which is preventing their lathering of soap, and that property is to be determined. For determination of hardness there is a method of EDTA. Now what is this EDTA method? We will see today it in detail. Now this method includes these following points: principle, theory, preparation of chemicals, procedure and calculations. So all these points must be there guys in your answer whenever they will ask the question on this EDTA method. Now come to the point now, EDTA. I already drawn here a structure of EDTA. It is nothing but ethylene diamine tetra acidic acid. So it is a tetra protic acid. It is having 4 different protons for the exchange purpose. So here I have drawn this structure also, ethylene diamine, and 4 different acetic acid groups are there. So in this way this particular agent or reagent we have to use, and that's why this method is called as a EDTA method. Now this method is also called as a complexometric method. What? Complexometric method. It is also having one of the reason that whenever this EDTA or ethylene diamine tetra acidic acid comes in contact with any positively charged metal ion, for example the metal ions which are present in our hardness, magnesium ions, calcium ions, any positively charged metal ions which is a di-negative particularly, it will form a complex. Means whenever this EDTA comes in contact with any positively charged metal ion, it will form a complex, and that complex is very much stable, and that's why it is called as a complexometric method. One EDTA molecule is responsible for the formation of a complex with one metal ion. That means it is having the proportion 1:1. But how we will use it? See here one thing that is very important. This EDTA, as it is a ligand, it is a very stable structure. It is very difficult to react it. It is very difficult to get soluble in water. That's why we use disodium salt of EDTA. Means this EDTA is, as it is having 4 different acetic acid groups, these H positive ions or protons are firstly replaced by sodium. So I can draw this structure here, CH2, which is very similar with EDTA. These 2 different amino groups are there, and these amino groups are attached to CH2COOH. Is it? But here what we want? We want disodium salt of EDTA. So instead of this H which is there in acetic acid, there will be some of the exchange, and disodium salt means sodium ions must be there. So here 2 hydrogen atoms are replaced by 2 sodium atoms, and in this way there is a formation of disodium salt of EDTA. Disodium salt of EDTA. Okay, and it is generally used because as it is a salt, it is very much soluble in water, and it will that reactions which are further that are very becomes very easy. So this is the disodium salt of EDTA which is generally used in labs. So this disodium salt of EDTA whenever comes in contact with this positively charged ion which is there as a metal ion, it will form a complex. Just see here, as soon as it will come in contact with this positively charged ions, a single metal ion, any single metal ion, so this hydrogen and this sodium ions and this hydrogen, they will get exchanged, and here in between any positively charged ion, for example this magnesium ion, there is a formation of such type of bonds in between, and there is a presence of one lone pair on nitrogen, it will also form a bond and form such type of a complex structure which is very stable. A single dipositive charge ion is connected with a nearly 6 bonds, that is coordinate type of bonds, and as this number of bonds are there, this structure becomes complex, and it is very stable complex. Is it? and on this basis of this particular formation of complex, this total method depends. That's why this EDTA method is also called as a complexometric method. Number of times this question can also be asked that why it is a complexometric method, or this question can be asked directly that determine hardness by complexometric method. At that time we should know that it is nothing but EDTA method. Okay, so this is the main theme just behind it, that how to form a bond. Now we will see the next topic, that is the point wise we have to move ahead. Now see here, first of all there is a first point which is there, which is called as a principle. Now what should be its principle? First, principle means it is a just a one sentence about the total reaction or total method. See here, when EDTA molecule comes in contact with any positively charged ion, it will form a complex, very stable complex in 1:1 proportion. That's it. This is about the principle. When EDTA molecule comes in contact with any positively charged ion which is hardness causing, it forms a complex in 1:1 proportion. Over. Now next point is theory. Now in theory the different points comes, like how that reaction occurs. So whenever we will carry out this procedure, we will come to know that what actually we are doing. But theoretically what is happening, that we have to see first. So whenever we will do procedure, that there will be just, this is the hard water which we will use for the determination of hardness. Then it is treated with, first of all, indicator. Indicator is there only for giving the color change, for indicating, for getting end point that your reaction has been completed. So EBT we have to add. At the same time we have to add buffer solution. Buffer solution is a solution which is made for the maintaining pH of the total reaction constant. That is basic pH 10. So the total pH of this total reaction is being constant, and then if it is constant, then only this reaction is possible. So that's why we have to add this buffer solution. There is no any another role of this buffer solution in our reaction. Okay. So after addition of this EBT and buffer solution, this hard water is having, just we will consider Ca positive ion. So hard water is having this positive charge ions, not H positive and OH negative will react with EBT or buffer solution, but there is a reaction of the Ca or Mg type of ions, because they are there for the hardness cause. So this Ca positive ion reacts with EBT to form Ca-EBT complex. Now as this EBT is a dye, it is iriochrome black tea. Its name is iriochrome black tea. It is one of the digest, but it is blue colored, though its name includes black, but it is blue in color, and it shows color change from wine red to blue, not blue to any, wine red to blue. Now why this wine red color is there? Because see here, as soon as this Ca positive ion comes in contact with EBT, there is a formation of Ca-EBT complex. As this EBT is just like to that of EDTA, EBT is also one of the acid which is having sulfonic acid group in it, SO3H. It is having a particular structure also. And when this EBT comes in contact with Ca, it is again, it removes its H positive ions and get reacted with Ca to form Ca-EBT, though it is unstable, but formation of complex is there. Okay, and then we have to add here EDTA for getting proper color change. And whenever this EDTA is added, EDTA is more powerful. We are using not EDTA but disodium salt of EDTA, and here we are writing EDTA because when it dissolves in water, it will form negatively charged ion. All the ions will be removed, whether it is H positive ion, whether it is sodium ions, but they are reduced. So that's why we need only that negatively charged ion. Only for getting the solubility we are using disodium salt, otherwise it is EDTA. That's why I wrote here EDTA. So whenever this EDTA comes in contact with Ca-EBT complex, what happens? As this EDTA is more reactive over this displaces this EBT and forms a complex with calcium ion. So Ca-EDTA colorless complex will be formed there. It is a colorless and very stable complex. Okay. At the same time, there is a removal of this EBT in the solution. In this way, there occurs the reaction which we have to mention in the under the heading of theory. So in this way, there occurs the reaction. Now, I think you are getting all these things. And what type of color change we will get? See here, when at hard water, we know water, it is colorless always. It is having the positively charged ions. EBT, it is blue colored indicator. Okay, this EBT is blue colored indicator, while this buffer solution is not playing any role in this, just it is added for maintaining its pH constant. Then this blue colored indicator, when it forms CaEBT complex, it is wine red in color. So that's why as soon as we will add this EBT into the water, it will form wine red colored complex, and that complex is a very important to see to get the proper knowledge about the reaction. So this wine red colored complex we will get at first. Sometimes we can get confused that whether its color is wine red or blue of that indicator, but it is not the color of indicator, it is the color of complex, which is somewhat unstable. And now as soon as EDTA is added, EDTA gets its position and displaces this EBT. So as this EBT is blue in color, our solution will become blue. In this way we will get color change from wine red to blue. Okay, you might have understood this, guys. Now we will move forward. So this all is about the theory. You have to mention all these things in the theory. How we will write them? In the theory, whenever the reaction occurs, at first there is addition of EBT and buffer solution. EBT is a Eryochrome black tea, it is just a dye, it is blue colored indicator which will give us color change from wine red to blue. As soon as it is reacted with the positively charged ions, it will form a unstable complex which is wine red in color. Okay, and then whenever EDTA is added in the same solution, there is a formation of metal ion EDTA complex which is the most stable, which is in the form of 1:1 proportion. So that you have to mention there. Okay, now here we have completed our second point. Now come to the third point, preparation of chemicals. What type of chemicals we will require? First of all, we will require standard hard water. We should know that what is the concentration of that water, and that's why it is a standard hard water. Then second, we will need EDTA solution. Okay. Third, we will need buffer solution. Then we will need unknown water sample. Then lastly, we will need that EBT indicator. Okay. All these chemicals we have to prepare. So first of all, standard hard water. As we know that standard hardness causing salt is CaCO3, calcium carbonate. Why it is a standard hardness causing salt? I already told it or give about idea about it in the my prior videos. But once again, that why it is used for it is used as a standard hardness causing salt, because it is having its molecular weight 100. So it becomes very easy for the calculations, as it is having its molecular weight 100, as well as CaCO3 is that salt which is very much soluble in water. So that's why it is considered as a hardness causing salt, and number of times it is there as a hardness causing salt. So that's why it is considered as a standard hardness causing salt. So as I said here that it is having a molecular weight 100, just we will use 1 gram of EDTA, 1 gram of CaCO3 added in 1 liter of distilled water. So that we should prepare the solution of this standard hard water. So I think you got this, that 1 gram of CaCO3 is there in 1 liter of distilled water. There is a preparation of it happens a preparation of that standard hard water, just 1 gram in 1 liter, so that there should be 1 milligram CaCO3 in 1 ml. We need this particular proportion to solve the next problems. So in this way there is a preparation of this standard hard water. Then EDTA is having its molecular weight 372. So we will take 372 grams of EDTA, so that there is a preparation of 1 molar solution of EDTA. So 372 grams of EDTA, and in this there is addition of some MgCl2. MgCl2 is added for formation of a stable EDTA, particularly the stable EDTA. So just a few drops of this MgCl2 is added there. So MgCl2 plus this 372 grams of EDTA solid, that is a disodium salt, and a remaining solution is prepared by adding distilled water again to make it total 1 liter. Okay, according to how much we need, according to that we can change its proportion of these chemicals. Okay, then buffer solution, as we have to maintain the pH constant 10. The buffer solution must be prepared in proper way. That first of all, this buffer solution is called as a NH4OH NH4Cl buffer, that is sodium hydroxide sodium chloride buffer. So how it is prepared? It is prepared by adding liquor ammonia NH3. Liquor ammonia, it is very pure, 99%. This ammonia is taken 567 ml. It is liquid in state at a room temperature, but if it is placed in an open place or just removing lid, it can be evaporated easily. So 567 ml of ammonia, and in this we will have to add NH4Cl, which is solid in state, just 67 milligrams. So when both the chemicals are added, again make up its level up to 1 liter by adding distilled water. Make up its level 1 liter by adding distilled water. Okay, 1 liter means remaining distilled water is required. 567 plus this plus distilled water, and then shake it well. You will get the solution of buffer solution. It is to be used very carefully. And last is this EBT indicator. Last one, EBT is dye. As already I told you that dye is already there in market. Just take a 0.5 milligram of dye by weighing in a weighing machine and add 100 ml of ethyl or methyl alcohol in it, so that there is a formation of a particular dye. And this dye will be there, just we need a 2 to 3 drops of EBT during each time. So it is sufficient for number of reactions, 100 ml. So in this way there is a preparation of dye, and this unknown hard water sample is nothing but unknown, that is any hard water sample from the tap. In this way these all the chemicals are prepared. Hope that guys you all are getting this. Now next point is our procedure. Now in procedure we have to carry out 3 different steps. In first step, preparation of, that is the formation of a reaction with a standard hard water. Second is reaction with the unknown hard water, and third is reaction with a boiled hard water sample. So first we will carry out our procedure, that is with a standard hard water sample. Now for this procedure it must be carried out in the lab. So we will need some apparatus from the lab. Just see here, there is a one burette. You know guys, this is the burette. It is having its 0 mark. Okay. Then there is one pipette. For our sake of convenience, I am drawing here a structure. Actually my drawing is not very good. So this is pipette, this is burette. And here we will need one beaker, and very important is conical flask. All these apparatus will be there. So at first we will take in this conical flask a water. That is, firstly we will use a standard hard water, because first step is with a standard hard water. So this standard hard water, at first we will take in any volume into this beaker. It is beaker. Then with the help of this pipette, it is suck out, that is we have to pipette out it nearly 50 ml. So 50 ml of water is pipetted out and it is passed into this conical flask. So it is 50 ml of standard hard water. Okay. Then in it we have to add 2 drops of EBT indicator, as it will show us the color change or the equivalent point. Then third, we have to add here a buffer solution. Buffer solution, its use is only for maintaining pH constant. So by adding this all the 2 ingredients into this particular hard water, our color of this solution will become wine red. Okay. Now this wine red colored solution is to be titrated with this EDTA, which is there in the burette. So it is EDTA, which we have prepared just now. Okay. EDTA solution. It is to be filled up to 0 mark. It is just reverse counting 0, 1, 2, 3, 4. So we will fill it up to the last mark. It will become 0. Okay. Now this conical flask is to be used for the titration just against the EDTA solution from the burette. So dropwise EDTA solution will be added into this, and we will see that whether there is change or not. So until the color changes from wine red, this color changes from wine red to blue, this EDTA will be added into the solution. And in this way, once there will be that point that when we get the color change from wine red to totally blue, in this way there will be insertion. For example, here there is a 22 ml EDTA. For example, this 22 ml of EDTA is required to neutralize this or complete this reaction. Means to get color change blue, we will require 22 ml of this EDTA. So this EDTA, volume of EDTA which is required, is considered here as a volume of EDTA for standard hard water. EDTA for standard hard water is required is equal to V1 ml. Just this 22 is considered as a V1 ml. Got this? In this way we have to carry out the all three processes. For example, during second time, only difference is that the standard hard water which was there is replaced by unknown hard water sample. So during second time, take 50 ml of unknown hard water sample, then add again 2 drops of PBT, add here 10 ml of buffer solution. 10 ml of buffer solution, its volume was 10 ml. Then again you will get wine red color, titrate with EDTA from the burette, again by making its level up to 0 mark. Means this is to be made up to 0, and then it is again there will be drop up or there will be addition of this EDTA into this conical flask. Then again during second time those reading we will get that to be considered. So if that volume of EDTA during the unknown hard water sample, so it is considered as V2 ml. Okay. Now during third time there must be the use of boiled water sample. So there is a one procedure for boiling also, just I will say it. At first we have to take 500 ml of conical 500 ml of beaker in which 250 ml of accurately measured hard water, those water unknown hard water which was used sorry. Okay, and then it is boiled at about 100 degrees Celsius because it is a boiling point of water. It is to be boiled continuously for half an hour without putting any lid on it. So in this way there will be evaporation. At the same time there is a accumulation of some dirt at the bottom of that water, and then it is to be filtered by putting it at a room temperature, and then it is passing to the another volumetric flask which is of 250 ml. Okay, and then that volume is make up to 250 ml by adding distilled water in it. In this way there is a formation of a boiled water sample. Okay, you might have idea about it. Now I think you understood it. Okay. Now there is a preparation of boiled water sample. Now instead of this first time we have used standard hard water, second time we have used unknown hard water, and now this third time we have to use boiled water sample. That sample just which we have prepared. Okay. Now just take again a 50 ml of boiled water sample. Again carry out the procedure like addition of 2 drops of PBT, 10 ml of buffer solution, shake it well, and then you will get wine red color. Again titrate it with EDTA by making the volume up to 0. During any time you will have to make the volume 0, and then again you will get a third reading which is for the boiled water sample. Why we are doing this for boiled water sample, guys? It is because we know that there are two types of hardnesses. Number 1 is a temporary and number 2 is a permanent. And temporary hardness can be removed by boiling process. So here we need both type of hardnesses. Firstly we will get total hardness, then we will get permanent hardness, and then we will get temporary hardness. So here by boiling the water we have removed temporary hardness and there is remain only permanent hardness. So for this studying all these types, we are doing here all the 3 types of calculations. So volume of EDTA for boiled water sample. For boiled water, this is important. Okay, it is considered as V3 ml. Okay guys, I think you have now the idea about this all what is their procedure for all the 3 steps. Okay, now we have to move towards the calculation, which is the last point of this method, and which is also very important. Without writing this point you will not get the total marks. So just come to here that it is a calculations. So first of all, how we have prepared the standard hard water sample? by adding 1 ml of 1 milligram of CaCO3 in 1 ml of distilled water. So this thing is to be very important to seal. It will require to us. So this is about the step 1. There are 3 steps, we have to consider all the 3 steps. Now 50 ml of, what is our reading? 50 ml of standard hard water we took, is it? And then we have got V1 ml of EDTA solution, is it? Yes. If you don't know, if you forget, then just revise the video and see once again that for the 50 ml of standard hard water we had required V1 ml of EDTA. Okay, so from this V1 ml of EDTA, we have to, here standard hard water we have considered, but we want this hardness in terms of CaCO3 equivalents, is it? As it is a standard hardness causing sum. So for 50 ml of standard hard water, V1 ml of EDTA, but 50 ml of standard hard water contains 50 milligrams of CaCO3, is it? 50 milligrams of CaCO3 as we have prepared it here, 1 milligram for 1 ml. Okay, so from this we can write that 50 milligrams of CaCO3 is equal to V1 ml of EDTA, is it? Just see once, twice, and make this sure that you understood it properly. Okay, now we want for 1 ml of EDTA. For getting the standard positions, standard calculations, we have to consider for 1 ml of EDTA. Therefore, from this condition, what can we say? For 1 ml of EDTA, we will require how much CaCO3? This 1 ml of EDTA, this V1 will be transferred to the another side. So, this 50 upon V1 milligrams of CaCO3. Is that clear? CaCO3. In this way, we have got this very first statement. 1 ml of EDTA is equals to 50 upon V1 milligrams of CaCO3. It is from the all the theory or procedure which is there on for the standard hard water. So this is our first condition. Okay. Then as this board is small, we have to just rub all the things which are there. This will remain as such. Then we have to move towards step 2. In step 2, you know guys, what is the calculation or what are our readings? 50 ml of unknown hard water sample. Unknown hard water. We have required V2 ml of EDTA. Is it? Yes. Now this V2 is considered as V2 into 1 ml of EDTA. Okay? V2 into 1 ml of EDTA. So therefore, 50 ml of unknown hard water is equal to V2 into, but what is 1 ml of EDTA? 1 ml of EDTA is equals to 50 upon V1 milligrams of CaCO3. Just put these values here. 50 upon V1 milligrams of CaCO3. So this is the statement for our second step by putting the value of 1 ml of EDTA. As 1 ml of EDTA is equals to this thing, 50 upon V1 milligrams of CaCO3. But now guys, this is for 50 ml of hard water because we took 50 ml for the sample. But we have to calculate for the generalization, that is for 1 liter. Means whenever we will write its unit, it is per liter. Is it? So that's why we have to calculate from 50 ml to 1 liter. So 1 liter is equals to 1000 ml. So 1000 ml of unknown hard water sample is equal to, what will be there? V2 into 50 upon V1. That from 50 we are calculating. So therefore we have to divide it by 50, and for 1000 we are calculating. We have to multiply it by 1000. Okay. Now in this way, this 50 will get cancelled, and what we will get at last? V2 into 1000 upon V1. That is milligrams of CaCO3. So this is our calculation for the unknown hard water sample. Hope that guys you are getting it. You are trying, means just try to understand. If it is not understood in a first watch it number of times, but this is a very important process for the study. Okay, so this is about the second step. What we have got here, we have got that 100 ml of unknown hard water sample is equal to V2 upon V1 into 1000 milligrams of CaCO3. So what is it? It is nothing but that particular hardness, that is this amount of unknown hard water sample is having this type of hardness. Okay, this is the hardness which is there. Okay, now we will move toward the boiled water sample. Again in the same way for the boiled water. So it is the step 3, 50 ml of boiled water. So during boiled water, what was our reading? 50 ml of boiled water is equal to V3 ml, is it? V3 ml of EDTA. Again we have to put the value of 1 ml of EDTA just. So is equal to V3 into 1. 1 means 50 upon V1 milligrams of CaCO3, is it? So milligrams of CaCO3. Again we have to calculate, it is for 50 ml, is it? We have to calculate again for 1 liter, that is 1000 ml of boiled water sample. Okay, is equal to V3 into 50 upon V1 into 1000 upon 50, in this way, milligrams of CaCO3. Again here 50 will get cancelled, and what we will get at last? 1000 ml of boiled water sample is equals to V3 into 1000 upon V1, milligrams of CaCO3. So what we have got here, it is the hardness which is there in our boiled water sample. And as we have removed already the temporary hardness from the water to make it boil, so this is the hardness of permanent hardness only. While this hardness is a total hardness, because during using this hard water we have not done any procedure with a unknown water sample. It is just taken and used. So from these two, as we know that total hardness is equal to permanent and temporary both. So by subtracting this hardness from this total one, we will get a temporary hardness. So what will be the equation for temporary hardness? That is equal to, as we will write it as total hardness is equal to permanent hardness plus temporary hardness. Okay, so what will be the temporary hardness? Temporary hardness is equal to total, obviously total minus permanent hardness, and just we are putting these values. So here by putting these values here, C is equal to, what is the total hardness? V2 into 1000 upon V1. Okay, and we have to subtract from this we have to subtract permanent hardness, that is just V3 into 1000 upon V1, and this is what? Milligrams of CaCO3 again, because all is having the same type of unit, or that water is in the same form. So in this way, what will be the temporary hardness? This 1000 will get common, 1000 is common here, and V2 minus V3, as it is having the same type of denominator, it will remain as such. So it is milligrams of CaCO3. Okay, so after this last equation, you have to mention that what is V1, what is V2, and what is V3. So what is V1? It is the volume of EDTA which is required to neutralize 50 ml of unknown hard water sample. What is V2? It is the volume of EDTA which is required to neutralize 50 ml of boiled water sample. Sorry, V1 ml, it is the volume which is required to neutralize standard hard water sample. V2 is the volume of EDTA which is required for the neutralize unknown hard water sample, and this V3 is the volume which is required to neutralize the boiled hard water sample. And in this way we have got the all up to the last, we have got here the result for the temporary hardness. But if there are some numericals on the depending on EDTA method, these formulas we can easily use. So in this way guys, today we have seen the somewhat lengthy topic of EDTA, but it is very easy and simple and very easy to understand. So that's why you watch it once again number of times you can watch it easily because it is very easily available. And if you like it actually, then you only like it, share it and subscribe it, and also click the bell button so that you will get such type of videos whenever the videos are there in the on the YouTube. Just thank you very much. Thank you for watching.